let's go over another premium medium question that I struggled with and could not solve, but you live and you learn. So now we're given the root of an n-ary tree. Basically just means that instead of left and right, you're given children, which are lists. Kind of a weird formula, weird format, but yeah, I wish they would just make this more clear, but that's fine. And so you want to compute the diameter of the tree, which is basically from the root node or any node down to the leaves, what are the longest two paths? So you can see from the picture, this would be 1, 2, 3, 4, 1, 2, 3, so it's 7. You count the edges, 1, 2, 1, 2, 1, 2, and 1. The hardest part about this question is figuring out how to freaking parse the input because it's super confusing, but I looked at a solution and I'll show you how to do it. So, okay, self.result is 0 because we want an integer, and then we want the root. We want to call a depth first search, and then define our base case. If not root.children, then return 0 because the depth cannot be increased anymore. If that's not the case, we're not in the base case, then we can say for child in root.children, it's our current node, and we're going to call, and we're going to say keep track of the max depth, which is going to be 1 plus the value of the previous recursive call, because it's going to go here and it's going to keep adding 1 to keep digging down from 1 to 3 to 3 to 5. And let's call this first and second because we want to keep track of the biggest two heights. And then here we can so we get our max depth, and then we can say if the max depth is bigger than first, then let's try to keep track of the previous first, and this is going to be set to first, or this is going to be set to first, and then first is going to be set to max depth, and then this is going to keep track of the value of first before first changes, and then second is going to be set to pre-first. And also, if that's not the case, then if max depth is bigger than second, then second equals to max depth. Because this is the other case when the current max depth is not greater than first, so then the second also has to keep track of it, because first would be less than or equal to second in that case, I think, I'm not sure. Either way, these are keeping track of the two highest max depths, and then now we can compare self.result to first plus second, because we want to add the two together and see if it's bigger than the historical, and then we return first because first is less than or is always going to be greater than or equal to the max depth of the two branches. And now we can just return self.result, which is going to be a result. And there you go. So that's it for this video. Thank you for watching and stay tuned for more.